Ever wondered how the current state of artificial intelligence is evolving? Well, Microsoft's latest innovation, the GRIN-MoE model, is making waves and changing the game. The traditional mixture of experts, MoE model, uses sparse computation, activating only a few modules at a time, making it efficient for big tasks, but facing issues like optimizing gradients. The new GRIN-MoE model tackles these problems using specialized features, preventing token dropout. These features have made the MoE models more scalable and better performing, further assisting AI advancement. The GRIN-MoE, or Gradient-Informed Mixture of Experts, is a breakthrough AI model designed to enhance the power and scalability of the traditional mixture of experts models. By addressing the limitations of older models, it aims to boost performance in complex tasks. Let's talk about some of its key features. First off, it uses sparse computation, meaning it only utilizes a subset of parameters, making it incredibly efficient. It also uses sparse mixer v2 for accurate gradient estimation, and sets up model parallelism to prevent token dropout. The result? High performance and efficient training. But it's not just about technical prowess. GRIN-MoE has real-world applications. It can provide in-depth descriptions and answer questions on images, recommend products based on user preferences, compute 3D molecular structures for drug target discovery, and even build precise climate models for better disaster preparedness. But how does it work? GRIN-MoE uses sparse gradient estimation for expert routing and sets up model parallelism to avoid token dropping. It features 16 experts per layer, activating the top 2 for each input token. This approach reduces active parameters while maintaining high performance. Sparse mixer v2 improves gradient estimation accuracy. Model parallelism spreads tasks across devices, speeding up training. GRIN-MoE shows over 80% throughput compared to dense models and scales well for complex tasks. It's efficient and scalable, perfect for handling intricate jobs. In terms of performance, GRIN-MoE shines across various benchmarks, particularly in reasoning, mathematics, and coding. It outperforms many open source models with similar active parameter counts, showcasing its efficiency and scalability. It outperforms models such as Mixtral 887b and Llama 38b. It even surpasses Mixtral X22b on most tasks, showcasing its efficiency and leveraging its architecture. However, the evaluation on LiveBench 2024-0725 reveals some limitations of GRIN-MoE. It underperforms in natural language tasks. This discrepancy is likely due to the specific focus of its training data on reasoning and coding abilities. When compared to other models like Phi 3.5 MoE and Mixtral MoE, Phi 3.5 MoE has 42 billion parameters and activates 6.6 billion parameters with 2 experts using more resources. Mixtral MoE has 45 billion parameters with 8 experts per MLP, making it resource intensive. GRIN-MoE uses sparse mixer v2 for better gradient estimation and avoids token dropping. Unlike it, Phi 3.5 MoE relies on supervised fine-tuning and other optimizations. Mixtral MoE is a decoder-only model, selecting from 8 parameter groups with 12.9 billion parameters per token. Overall, GRIN-MoE excels in efficiency and scalability without needing extensive computational resources. It's ideal for high-performance tasks, especially in coding and math, making it superior to Phi 3.5 MoE and Mixtral MoE for such applications. Want to try it out? GRIN-MoE is accessible via GitHub and Hugging Face. You can follow step-by-step instructions for local code execution or use Docker for a smooth setup. An interactive demo is also available for a hands-on experience. However, like all things, GRIN-MoE has its limitations, particularly in natural language tasks, because most of the training garnered was from reasoning and coding datasets. But the future is promising, with improvements focusing on incorporating diverse datasets and refining gradient approximation techniques. So overall, the GRIN-MoE model is a highly efficient and scalable AI tool, excelling in complex tasks like coding and mathematics. Its innovative architecture and resource-efficient design make it a game changer in the world of AI. That's all for today. If you found this video informative, don't forget to like and subscribe. See you in the next one.